Thank you for joining me this evening as we talk about the Google Noto Project. I will be reflecting on our experience of several years working on this project and sharing thoughts and ideas that reflect my role as implementer. So what is the Noto Project? The Noto Project was initiated at Google several years ago to provide fonts for all the scripts supported by the Unicode Standard. Now, that's a very, very ambitious undertaking. As you know, the Unicode Standard supports many, many scripts, and in this list you see some of them. The idea that one day we would implement all of these fonts would have been a dream a few years ago, and it's a dream come true, one that I really did not expect to come true this soon. The Noto project enables all Unicode encoded scripts by making available fully functional fonts that support them. The first phase of the project included all the scripts in version 6 of the Unicode Standard, and I remember when that looked like an awful lot. By now, most of the scripts in Unicode version 11 are supported. So in total, it's around 135 scripts. Not all of those are pertaining to a language. Some are symbolic, like music, mathematics, and various symbols, but the larger part goes to languages. In this project, the arrangement was that Google funds all the work that is outsourced to contractors. So the fonts are produced and they're made available to the public under an open source license. That's the destination of fonts. Everybody knew that right from the very start. So Google chose two main contractors to carry out the font work. Adobe got the Chinese, Japanese, and Korean part of the fonts, and Monotype got most of the remaining scripts. In early 2002, I joined the project as it was transitioning to this new name of Noto. Now, when I first heard that, I thought, Noto, that sounds very Japanese. And I found out there's a Japanese peninsula actually called Noto. But that's not the reason behind the name. When I inquired further, I'm sure you've all had the pleasant experience of typing in a character that's not in your font and getting this square instead. Well, people started calling these squares tofus. So tofu, like a cube of tofu. And the idea behind the Noto project was no tofu. In this project, we basically have two anchor fonts. The Latin fonts called Noto Sans and Noto Serif provide the leading style that all the other scripts are supposed to be compatible with. Now, at the beginning of the project, people had maybe unrealistic expectations that everything would sort of look like these. And then, of course, it only took a few scripts to realize that we can't really make everything look like this, but we can make them cohabit peacefully. So basically, in terms of darkness, in terms of color, appearance, that they look compatible in some way with these two leading fonts. Also, the question in the beginning was often asked, is the Noto project going to build one huge font that supports all scripts? And those ideas weren't so clear. As time went on, it clarified, and basically the module approach won out, is that basically various scripts will have modules, and then people can combine modules to get an overall effect of support for various scripts. Now, also the division of serif and sans serif in Latin, Greek, and Cyrillic typography doesn't really apply all that well to other scripts. And we had many discussions and arguments at the beginning. I was for dropping not using the name sans and serif in other scripts, but basically Google decided that they would do that. So eventually what happened is that the reasonable pairing of these is that if you have a sans Latin font, something contemporary looking in another script would match that, and more traditional looking styles would be paired with the serif. And that has worked out fairly well. There were always discussions. Now, the process for each script consisted of several steps. Here, for example, you see one of the earlier proposals, a proposal for sans Tibetan. And basically, every script in the beginning that we were going to implement had a proposal prepared for the design proposal submitted to Google, and it was reviewed and critiqued. And then after it gained approval, then we moved on to implementation. I remember there being many, many discussions about this style of Tibetan being called sans. And in the end, another style got added many years later. After a design proposal is critiqued and design is changed as needed and accepted, then from there we proceeded to proofing. Here you see a syllabic script called Canadian Aboriginal Syllabics, and it supports the Inuit, Cree, and other indigenous North American languages. Here you see a proof sheet for a script called Bamum, an African script. Now, once we've studied on our own and gained as much as we could, information as we could about a particular script, very often we were left with questions about small details. So in this case, what you're seeing here is a sample from the Tifinagh script, and that's used for Berber, Tuareg, and other related languages in North and Central Africa. And the questions we had were about the use of combining marks, these accents, and how they would be placed, because that's a fairly new development in that script. Now, to answer questions of this sort, we had exchanges with consultants or experts, as you might call them. And we exchanged questions and sometimes received good answers. So here we see a proof sheet showing the changes in combining marks with that script. And the proof sheet was supplied by the consultant. Now, from proofing the basic symbols after outline design, you basically have to test functionality. At the beginning of this project, there were very few ways of testing things. And one of the available ways was a tool provided by Microsoft called Volt. And it allowed us dynamic testing of the shaping instructions of fonts. And in many cases at that stage, we were not able to do testing outside of that environment. Sometimes we could do the testing under Windows environment at that point. But in many cases, it was very, very difficult. Once we were satisfied with the font's functionality, we released it to Google, and Google made it available to the public. So after going through the cycle of working on many different scripts in the early stages, we began to see some trends, and we learned some important lessons. I'm talking about the first 2 or 3 years of the project at this stage. One of the first lessons learned is that it's very hard to estimate how much time a font will take, especially for scripts that are somewhat complex. And it was very often, we found out quickly that most often this time was way underestimated. Now I'd like to take a quick detour and explain a little bit what I mean when I say a simple when I refer to a simple or a complex script. Typically, we consider the Roman alphabet, the Latin alphabet, simple. In the top paragraph that you see here, it's rendered, the text is rendered in a typewriter font, and there really isn't much simpler than that. Basically, every symbol, every character has one available symbol, and it gets displayed. Nothing else is done to it. In the bottom paragraph, we have text set in the same set of characters. However, it's a handwriting font. And every letter has at least 2, 3, 4 different shapes. So even in a simple font, like Latin, the style can make things become complex. So simple and complex are not two exclusive worlds. It's a moving scale. So here's an example of Arabic script. Again, the 3 paragraphs shown here all reflect the same basic text. There's no alteration. The top shows rendition in a typewriter font. It's monospaced, not nice looking, very simple. This is what typewriters used to turn out. The middle section is a typical textbook face, and the bottom is a calligraphic style that's called nastaliq. Again, the top has the simplest rules. Every letter has 2 to 3 different shapes. The middle, it's 3 to 4 different shapes, and then many more for the bottom. So here again, for just one script, we have a big moving slide of complex to very complex. Now, we learned quickly as fonts were being released to the public that there is a third party at the table, sometimes invisible third party that we didn't always think about, but came to realize very quickly. This third party is the end user community. Basically, we came to realize that the font, even if it's accepted by Google, has not fulfilled all the requirements if it's not pleasing or at least acceptable to native readers. So contractually, something can be okay, and then we can have the stones and eggs and tomatoes flying back at us a few days after release. We never did anything intentionally bad, but people are very attached to the way they write their language, and they'll express themselves if they see something that's not pleasing to their eyes. So we have the challenge of implementing all these different scripts through designers who are not native readers of the scripts. And that is really a very, very big challenge. And what's amazing is that with talented designers, you really can do that. And it takes a special effort. Not everybody is able to do that, but it is achievable. Also, when we talk about experts, experts don't all come in the same flavor. Again, it's a moving scale. Let's say the ultimate expert would be somebody who's a native or near native speaker, reader of a script, and is also knowledgeable in the typographic conventions of the script. Now, that's sometimes been available, but it's only a handful of cases where this happens. Then at the other extreme of the scale is somebody who's familiar with reading a particular script and can speak out if something looks abnormal. They might not be able to even correct it, but they know when something doesn't look right. So since finding experts is quite a difficult thing to do for many of the scripts we had to handle, we learned to live with this moving scale. And in fact, even what I'm calling the lower level is often very, very useful because it gives an intuitive feedback that we would not have otherwise. Now, there's also another problem is cost. So our budget did not allow us to have an expert consultant who's paid on every script. That was not possible. So it tended to fall on certain scripts where experts were findable. The issue of producing something acceptable is obviously much stronger for scripts that are living and being used today rather than the historical ones. Critique. Once you release a font online, we realize that the comments can appear in hours or minutes, sometimes even. And people make very strong comments. Sometimes comments are frivolous, sometimes they're serious and right, but it takes time to review all of them and then sometimes to verify whether something is really important or not. So reviewing the received critique is usually something that nobody schedules for. But when you release something publicly on the net, the cycle is very quick. Finally, we come to testing. We came to realize that for many scripts, we were not going to find a good environment for testing. And we were going to have to build our own more sophisticated OpenType interpreter that could accommodate, can be extended for new scripts. We also needed that for more dynamic testing and being able to correct the functionalities as we went on. And in time, we did that. And without that, we would not have succeeded in completing this project. In the initial phase, we were lacking this facility, and as a result, we could only guess sometimes how something will render, and obviously mistakes showed up that were undesirable. So while I can't show you every script that we've worked on, I've chosen a few as glimpses, really, of the path we've taken. The few I've selected are scripts that differ widely from each other, and you'll get an idea of how broad the offering is in this project. So all I'm showing here are real documents that were used in proofs. These are not faked or synthesized in any way. I'm fortunate to have kept some of these. So here we're looking at the Burmese script, or Myanmar, as the newer name would be. And Myanmar is a syllabic alphabet, and it clusters things in groups. So, okay, we're not seeing my cursor, so excuse me, I'll have to point. On the top line, we're seeing, oops, I should stay here. Okay, here we're seeing the same pattern shown in two weights of the font, in the regular weight and in the bold weight. On the left, we see this S-like character with a vowel below, which is the U vowel, and what follows it is this circle, which is a tone mark. The tone mark in the bold weight was colliding with the form that follows it. This is a typical type of problem that comes up with in spacing when you go from a light to a dark font. So to get rid of something like this, basically you have to adjust the placement, and you often have to insert a synthetic space in between. Obviously, that takes work. So that means you write an instruction in the font that says when a combination like this or something similar happens, add space. Here we were reviewing errors that were pointed out by Google staff. In the early scripts, we were dealing with scripts that often had someone at Google that could read them, and some of the review was done there. So in this case, this was internal. Here we're looking at also the Burmese script, and we're seeing a very subtle logic error here where the accent that looks like a grave accent is sitting on top of a letter that doesn't belong to. It should belong to the one on its right. So we had some kind of logic error that caused this to happen, and obviously we fixed that. Now, you see there are two samples here, one from the Noto font and the other one from a Microsoft font. So it was useful when we could find other references to compare. As I mentioned, at the beginning of every project, we would submit a design proposal. There had been an earlier Armenian font, and it was deemed unacceptable. So we were very fortunate to find a young designer who had done very deep research on Armenian script. And here she took the old font and superimposed on it in red the changes that she was planning to make. And she presented this very detailed proposal with very, very fine informational notes. And the proposal was accepted, and this font became quite well liked. So where do you get detail on a newly invented script? It's very hard to get. Here we're looking at a script called Adlam, and we were very fortunate to be put in touch with the inventors of the script, two brothers, and they prepared this sheet for us, which showed the construction of each letter stroke by stroke. So here most letters are created with the 3 strokes, some with 4, and it gave us a better understanding of the forms that we were aiming for. This script was invented for the use to be used with the Fulani languages in West Africa, and it had a great success story. Here we're looking at a very unusual looking Indian script called Ahom, and in front of us is a proofing sheet, basically consonant plus vowel plus an R. This circle that you see is an R. And functionally, it behaves a lot like other Indian fonts, but its appearance is quite unusual. And here I've highlighted spacing that was too open in the top paragraph. And in the bottom one, I was critiquing basically the placement of vowel marks. You see the place highlighted. There was a clash between the base letter and the mark on top. Here we're looking at a very unusual number system that's a complement to the Coptic script called the APAC numerals. And this was just a first design critique of the numbers, and on top you can see the beginning of the Coptic alphabet, which looks very similar to the Greek alphabet in most cases. Here we're looking at a script from a long time ago. This is an extinct script from the Nubian kingdom of Meroe. This is a cursive style of the Meroitic script. And these are just early design comments. And on the top, you can see a handwritten sample that we use as reference. Here we're looking at also another extinct script called Old Permic that was devised for Siberian non-Slavic languages. And this is a simple proof of the various letters with the different combining marks placed on them. And below you can see an old manuscript sample. Here we're looking at another minority Indian script called Tierhooter. And basically it's being reviewed for the special combinations required for that script and general shapes, general comments on the shapes. Likewise here, another minority Indian script called Multani, and with small design comments. Now what's interesting about the Indian minority scripts is that many communities are hoping to revive the use of these scripts by having access to fonts, because at some point many of these scripts did not have typographic support. So the main scripts, the 9 main scripts of India, succeeded and completed their cycle and entered the digital age. But for many of the minority scripts, this is really a first step. Finally, we're looking at the Nastaliq style of Arabic script. Now, the designer who did this task wasn't only asked to design, we asked him to organize the design very systematically. So basically, he created a visual grammar of how things get composed. And you can see on the left, you see the rendering of a sequence as it connects, and then the Lego pieces on the right, how they get attached to each other. Now, this style is used in India and Pakistan, primarily for the Urdu language, but for several other languages as well. And it is really calligraphic. Implementing this in typography is quite a challenge. Here are more presentation forms that show how things overlap. This is an early stage proof sheet where basically words are coming together, are readable, but there are still a few bad choices of shapes that have to be further refined. And finally, at some point, we reach a stage where even very complex combinations like this are rendering well. Now, recently I was thinking to myself, isn't it a shame that this project wasn't started 10 or 15 years earlier? Then I started thinking again, would this project have been feasible 10 years earlier? And I came to the conclusion that it wasn't. And there are several enablers for this project that maybe we didn't think about at the time it started, but they added up to something that made things possible. In the year 2002, Debbie Anderson launched a project called the Script Encoding Initiative at UC Berkeley. And this initiative was meant to act as an advocate for lesser served scripts. Many of the scripts in the Unicode Standard belong to underserved communities, minorities. Most of these scripts would not be in the Unicode Standard today if it weren't for the work of SEI. So here you see a list of maybe 70 of the scripts that SEI is responsible for. There are more than we see here on the list. And if you've ever wondered what it takes to get a script enlisted in Unicode, encoded in Unicode, it's quite a process. Basically, you have to present a proposal that shows evidence that this writing system has been used, is successful, there are previous uses, and to be able to present give a functional presentation of the script and to identify all the characters necessary. This is a task that many communities would not have the facilities to do, and SEI has managed to do that for them. Another prime enabler of fonts, of the Noto fonts, is the OpenType specification. Basically, the standard defined advanced typographic features that would be defined inside fonts, basically embed in the fonts. It defines the data structures and their functionality. And 10 years before the start of the Noto project, this standard existed, and in fact had most of the finer points that it has in today's version. However, it hadn't received much implementation. So a lot of the functionality that we see available today would not have been available on earlier systems. Today, we find that OpenType is supported on most runtime systems. It's taken for granted. The next enabler is the Universal Shaping Engine. As part of the OpenType specification, the features and visual behavior of many scripts were formally defined by documents dedicated to the script. For example, if you wanted to do Burmese script, there was a document for Burmese that said how it functioned, what you should expect, things that change, and so on. If you wanted to write, to do a font for Hindi, there was a document explaining Devanagari as a script and its functionality, and on and on. Microsoft was preparing these documents. At some point, they were not able to keep up anymore. More and more scripts were being entered, and there were no general guidelines available for scripts that did not have a specific shaping document. Now, the Andrew Glass of Microsoft realized this, and he defined a new shaping method that's generally usable for new scripts, especially those of Indic descent. So this new general shaper called USE, the Universal Shaping Engine, is something that is a specification that can be implemented by anyone, and allows the definition of functionality for new scripts. Another great enabler is Harvbuzz. Harvbuzz is an open source based interpreter for OpenType format. It's authored by Behdad Esfahbod, and it has now gained broad acceptance as an independent, reliable interpreter. I see Behnam here. So we've used Harvbuzz to compare our shaping results against it, and have had many exchanges with Behdad about correctness and so on, and many open discussions. We use it now also through 2 web browsers that incorporate it, Chrome and Firefox. And its open source nature also allowed us to quickly report problems, discuss their fixes, and even suggest them. So for many scripts, it was the only interpreter that offered USE support. So in this way, we had 2 things to compare. If you remember, in the early phase, we had very few tools for testing, very difficult to compare a result against nothing. So in this way, we have at least a comparison, and we have colleagues with whom we can discuss the results. Finally, the last enabler is experience. 10 or 15 years earlier, we would not have had the collective experience with other complex scripts that has allowed us to dive into this great number of new unknown scripts. So it takes years to develop experience and knowledge. And again, all these various factors added together and gave us this result. So what is really the ultimate goal of the Noto project? The goal is to put functional fonts in the hands of each script community. Each script or writing system supports 1 or more languages, and each script serves at least 1 community. So whether a language is living or dead, it has a community. Dead languages are usually followed by groups of scholars. Living languages have a living community. So by having a font supporting a script, a community can really start to enter the digital age. And I was thinking, what steps does it take to really build a digital heritage for a particular script and its language? I think there are at least 3 steps. The first step is the script has to be encoded in Unicode. So to exchange data digitally, you have to have agreed upon codes. You can't have private codes. So the first thing is to have all the necessary characters encoded. Second, a font is needed to visualize existing text. Unless you can give it visual form, you can't read it. Thirdly, input methods have to be built that allow people to enter text. So once these three steps are fulfilled, the community can begin composing text documents to represent their cultural patrimony. Now, this may sound very nice, but there are obstacles. There are real practical obstacles. One of the big obstacles is that systems are not always receptive of unplanned scripts. So adding a font and an input method in some cases may be quite difficult. Laptops are much more flexible than smaller devices. Smaller devices tend to be more closed. So for example, in some cases where fonts became available, people were not able to add them to older phones because their existence wasn't really planned. So there are practical problems of that sort. Input methods might look easy to the technocrats, but might not be easy for a community that doesn't have technological resources. So thank you for your attention, and now I invite your questions and comments.